In this lecture, we'll learn about a new design pattern, namely the singleton design pattern. Whenever you're learning about new design pattern, you have to know that you're learning about the context and solution to a new software development problem. In this case, what's really the problem for the singleton design pattern? Shortly speaking, in your system, there's a single object instance that's being shared by all the other objects and they can be accessed, but there's only one single instance. That's the key. So we'll see in more elaborated details about how we can solve this problem here, what's its motivation, and what will be the solution. We'll get there. So let's first of all look at the learning objectives upon completing this lecture. Number one, we want to understand the modeling concept of expanded types or compositions. In your previous Advanced OOP course 2030, you learned about the difference between aggregations versus compositions. So now for compositions, if you recall, in your 2030 course, the way to achieve composition is by having constructs such as copy constructors. And you have to make sure there's no object aliasing, there's no sharing going on in your system. But you got to do it manually. But now, by using expanded types, you will be able to do it automatically. That's something we'll address in the first learning outcome. Number two, we'll talk about, about static methods in Java. But now, what about but static methods may not be the best way to really achieve like a single instance in your system. But we're going to introduce a new concept called once routine that's actually in IFO. So we actually compare these two programming constructs in two languages and see what's the pros and cons using design principle, namely cohesion. Okay, we'll get there. So objective number 3 is about export status. So this is some unique design features of the IFO language. So in Java, you can only say public versus private or sometimes protected. But for IFO, you will be able to say for a particular feature section, features over there are only callable by certain client classes. Then that one will be very useful for achieving the singleton design pattern. We'll also get there. Okay, and number 4 is about, as a first attempt for the singleton design pattern problem, we'll try to use simply inheritance by inheriting all the shared data to the child instances. And we will try to criticize whether it's a really good design solution or not. Especially, we're going to talk about the single choice principle you learned from the previous lecture and also the cohesion principle. We'll get there. And then finally, we'll present to you the singleton design pattern in IFO, which is going to use the once routines and also use the export status carefully in a way that can achieve the design goal. That's something we'll see. So this is going to be a lecture that we're going to build, make incremental developments on the concepts, and then eventually we'll present to you the singleton design pattern. That's the plan. Okay. Let's now, first of all, start with the modeling concept for expanded classes. Okay, so we may want to have objects which are, number 1, they are integral parts of some other objects. They're simply integral, which means they are not to be shared. Okay, that's very important items to keep in mind for one category of items in your system. Let's say, for example, if you talk about your person lab machines, every workstation has its own CPU, monitor, and keyboard. On the other hand, they also share the same network. So let's take a look at some visual illustration on this. Okay, so that's exactly what I just said over here. So you can see over here, let's say this is workstation number 1. This is workstation number 2. This is workstation number 3. For each workstation there, they got their own individual keyboard, which means these two keyboards are not being shared, right? They're simply just individual keyboards. So if you somehow got issues, if you make any changes on this one over here, it's not going to affect this one here. So they're completely independent. Similarly, for the CPU, they're also completely independent. For the monitor, they're also completely independent. On the other hand, there's certain item in your system that might be shared among other entities. For example, let's say this is the EECS computer network, in which case every workstation in the prison lab, they are connecting to the same network. So now in this case, you can see workstation number 1 is connecting to this particular network, and for workstation number 2 is also connecting to this particular network, and similarly for workstation number 3. What that means is, since you only got a network, only a single instance of the network, any change on this particular network object is going to be visible by all the sharing parties over here for all the workstation connecting to the same network. So that's the difference between sharing versus not sharing. Okay, again, recap. These concepts over here, the green one over here, so these are simply integral parts for your modeling, for your system. You can think about these guys over here are the integral part, and not to be shared. So you can think about these are more like the compositions that you learned in the previous course. No sharing. On the other hand, let's say for this network over here, so for this particular network object over here, that one is shared. So that's more like an aggregation. So this will be the shared part, shared instance or shared objects. And then in this case, that'll be more like the aggregation you learned previously. Okay, so please just note about the difference between aggregation versus composition. It's like a shared versus not shared. Okay, and then in your design, you should always decide which item should be shared and which item should not be shared. Let's just come back here. And then if you look at the slides, that's exactly the diagram I just described. So far we talked about the modeling concept for compositions versus aggregation. Let's say for compositions, how can we do it in an automatic fashion in IFO? It does support the syntax to do this automatically. So there's a new keyword you will have to learn about doing compositions automatically in IFO. So new keyword is called expanded. Okay, let's say, just give one example here. So let's say we got 4 classes. So we got keyboard, we got CPU, we got monitor, we got network. So these are just ordinary classes. Okay, and then let's say we want to declare our workstation class over here, and then let's say we declare different attributes here. You can see that for the network, it's just like before. So when you instantiate n over here, it's simply going to store the address of some objects of type network as before. But now in these 3 cases over here, for keyboard, for CPU, for monitor, we simply added the keyword called expanded. You can think about expanded simply means we're going to treat the keyboard K, the CPU C, and also monitor M like an integral parts for this particular workstation objects. They are not going to be shared. So that's what expanded really means. And then all the runtime property are going to be ensured by the IFO runtime automatically. And we will illustrate by one simple example in just a moment. Okay, so this is one way you can declare for compositions in IFO by using the keyword expanded. So that's one way to do it, meaning that we got just ordinary classes over here. And then when you want to declare variables, you simply say either expanded or not. Okay. The second way of doing it is like this. You can say, now I'm pretty sure every time, always, I want to use keyboard as an expanded type for compositions. Always, no exceptions. In that case, you can simply say it's going to be an expanded class, an expanded CPU, and the expanded monitor. One example for this would be, let's say, for the integer, boolean, and character. So if you look at in IFO Studio to look at the declaration for the class integer, you will see that it says expanded class integer, meaning that there'll be no circumstance under which we want to use the integer that's to be shared, like an aggregation. Always we want to use integer as compositions. Always it's going to be like an integral parts. Never share the integer. Okay, so now there'll be one solution you can go. In that case, you will say class network over here, and now you can see the difference here. So for example, you can see that monitor is an expanded class, never to be shared. Or on the other hand, network over here may or may not be shared depending on how you declare the variables. So now when you say workstation here, so now you can see these 3 declarations. We are referring to keyboard, for example, is referring to some expanded class. CPU is referring to another class, and monitor is referring to another expanded class. In that case, the network over here is referring to just a regular class. Of course, if you want to make the network also not to be shareable, you might just put expanded keyword over here if you like. But in this case, we just want it to be shared. Okay, so that's about these 2 different solutions over here. So now the question will be, which one should be more preferred? I would say which one is to be more preferred. Again, it's up to your need. Let me just switch to the iPad and then give you a little bit of sketch about how you should decide which one you want to go. Okay, apparently we got 2 possible solutions over here. One is you simply got a regular class over here, and then you simply just try to declare expanded when you need it. right? It's one example for keyboard. On the other hand, you can see the second solution over here. You simply say expanded class over here, and then you can simply just declare using keyboard over here, right? So they have the same effects programmatically. However, which one do you really want to use is completely up to you. Okay, so let me just give you some guidance very quickly. Okay, so for solution number 1 over here, okay, you will use this if the keyboard class, okay, I'm talking about this particular keyboard class over here, maybe either an integral or sharing part. So I'm talking about two possibilities. Either it can be integral or it can be sharing. So now in this particular case, it's really the integral that we are choosing. But if you want it to be, let's say, sharing, in which case you will simply, let's say, for example, if I really want the sharing part to be the case, in that case, I'll simply cross this out. So I will still get a keyboard class declaration over here, the variable declaration. So I would say solution number 1 give you more flexibility if you believe the class you are really trying to declare over here, it should be allowed, both possibility, either as an integral part or as a sharing part. On the other hand, for solution number 2, as I mentioned there, so because at the class level you already declared this to be expanded, right? So now I would say, so this would be the principle. So you would say use this if the keyboard, again, the class we are talking about, if keyboard should always be an integral part, which means it should never be shared. So it should be an integral part always, meaning that when you declare the keyboard over here, you will simply saying that keyboard should always be expanded over here. So now it will not be possible to say you want to give the k over here is not really not storing address of a keyboard objects. So whenever you're declaring some variable of type expanded, it will illustrate in just a moment, you're not really storing the address anymore. What you're storing is the entire objects over here. Okay, so now let me just do a very quick recap. You want to know when to use the first one and when to use the second one. I already told you the guiding principles. In this case, having this and having this, okay, with expanded over here. So they are effectively the same when you execute at runtime, meaning that for k to be declared as the expanded version of keyboard, k is not going to store the address of keyboard. Instead, it's going to store the entirety of the keyboard. So now if you recall this particular diagram here, we can see the keyboard is an integral part of the workstation. Rather than saying, for example, the workstation is really pointing to some keyboard object. It's not the case, right? It's not the case for expanded. Okay, just to clarify that. So similarly, so now since we, in the solution number 2, we also declare keyboard to be expanded itself. So that means when you're declaring k to be of type keyboard, it's also going to be an integral part without any sharing. Okay, so just learn about how to use a keyboard to use a keyword expanded and see which solution you want to go according to the guiding principles. Let me go back to the slides. The next one will be, we'll try to look at one programming example to illustrate the behavior of expanded versus non-expanded. So let's look at the example. We have one class over here called B, and notice that we are using the expanded keyword to say B is always expanded. It's not to be shared for its objects. It's more like an entirety every time you create a B objects. And we have a very simple command, change I, because we got some integer attributes I, and then we simply say have some new I, and then set it to be the new value for I. Okay, very simple expanded class called B here. And then we're going to worry about how the various usage of the object B or calling a command upon that is going to work at the runtime. That's something we want to see. So I didn't really show this over here, but for the code I'm going to run in front of you, you have to think about what if B over here is not expanded. If I take out the expanded keyword, what's going to be the outcome for that particular example there? But now we talk about expanded, so everything you expect on the non-expanded clause may not be behaving the same anymore. So that's something I would like you to do the comparison yourself, right? We're going to rely on you on that. Okay, so let me simply just move on to the iPad over here. So this clause expanded is what I said as before, and also we got a command, right? So now let's talk about this particular fragment of code. If you like, you can maybe pause the video and then think about what the check assertion should be, what the value should be. Think about it, and then you may want to visualize how the objects are being created as well. Okay, assuming that you have thought about it, let's say this. I will challenge you with the following question here. So you can see we are trying to declare, let's say, EB1 and also EB2 of type B. And we know that B is simply expanded, right? That's what we know. But now here's my question for you. You can see we are the first assertion we are trying to do, the check assertion over here. We are saying that EB1.I should be equal to 0. EB2.I should also be equal to 0. Based on what you have learned so far, don't you think there should be a void safety issue over here? Because you can see this is the very first line of the program here. We are kind of using EB1 over here for the very first time without first creating its objects, without instantiating it. So it seems like, shouldn't there be some void safety issue, void object call? Shouldn't there be some compilation error over here? That's my question to you. Okay, it turns out it's not an issue. Okay, that's a very important fundamental difference between expanded versus non-expanded objects. Okay, so now I want to say this: EB1 and also EB2, being that B is simply just expanded. So that simply means whenever you declare the local variables over here, declaration itself will be enough to actually create the objects to be initialized. So that's rule number one you should know about expanded type. So what's going to happen is, just by declaring EB1 and EB2 of type B, since B is expanded, so we're just going to have two objects over here. So this will be object number 1 of type B. And we also got another object over here. Object number 2 is also of type B. Okay, we got two objects over here. And then EB1 and EB2. Remember we talked about when you say expanded objects, you don't really have addresses because you don't have any sharing. So you can think about EB1 is over here and EB2 is also denoting the object directly rather than storing addresses. That's one thing you want to also remember. Okay. So now number one, there wouldn't be any compilation issue over here. So now how are the expanded objects created in the first place? The rule goes like this. If the reference over here, if the attributes over here, so we got I, right? So you got I over here and also you got I over here. If the type over here is simply just expanded or primitive, so I kind of will use primitive and expanded interchangeably, but it's not exactly accurate because expanded really means it's integral part and there should be no sharing, and primitive is more referring to just integer, boolean, character, etc. You can think about primitive or expanded. But expanded are not necessarily always primitive because, for example, the B over here is not primitive, but it's also expanded. Okay, hopefully you can see my point. But I think in a loose sense, it's okay to use them interchangeably if the context allow. Okay, that's something I would like to point out. So now in this case, because this attribute over here is simply integer, is expanded. So now in that case, we'll simply initialize by its default value. In that case, it would just be 0 and 0 over here. So the consequence of declaring EB1 and EB2 is simply that we're going to initialize two objects over here where every attribute in that particular class, for example, I over here, will just be initialized to be 0. So you can extrapolate from this and think about what if I is of type Boolean. In that case, it will be initialized to be false. And what if I is declared to be real number? In that case, it will be initialized to be 0.0. And what if I is of some reference type, not expanded? In that case, it will be initialized to be void, okay, the default value. Okay, you can see and so on. Okay, so now let's based on this, if we try to check the first one, EB1.I is 0, EB2.I is 0, is actually true. Okay, so the first one is going to pass. Okay, so I'll just put a check mark over here. So it's going to be passing. Okay, and now let's look at the second one, which is also important to understand. When we say EB1 equals EB2, so now you can, based on what you understood from before, when we say equal sign, it's really important to note over here. We are not comparing addresses. Not comparing addresses. Instead, you can think about EB1 and EB2. Whenever you use equal sign over here, when both sides are simply just expanded. In that case, it's as if you say EB1 tilde EB2. You're just comparing them by contents over here. Okay, so now in this case, when you say EB1 equals EB2, you can see even though they're different objects, however, their values over here are simply just the same, just simply 0 and 0. So that'll be okay. So that's also passing. But it's passing not simply because their contents are the same. Think about this. If this one is going to compare addresses, it would have been false, right? But now it's not false because they do have the same contents over here, right? Okay, let's move on. And then let's say this. EB2 that change I, which would be changed to 15. So EB2 is over here. Change I, you're going to change that to be 15. Okay, so now we can do the comparison very easily, right? So now EB1I is equal to 0. True. EB2I is equal to 15. That's also true. So this is also okay, right? Okay. Hopefully so far so good. And now, if you say over here EB1 not equal to EB2, again, this equal sign over here is not comparing addresses. It's as if we said not tilde. So we're saying that their contents are not the same. Well, that's true because you're comparing 15 versus 0 over here. So that's actually true. Okay. Again, whenever you use the equal sign for expanded type, it's as if you use the tilde over here, which is going to compare just the contents, right? Of course, how you compare the contents might depend on how the is equal is redefined. Okay. Okay, let's now do another one, which is also very important. When you say EB1 is assigned to EB2, right? So now that's also very important for me to point out. If these two variables were reference type, in that case, assigning the address to another one is simply copying over the address. That's how aliasing can occur in the case of reference type. But since EB1 and EB2, they are simply of expanded type, so it's different. Okay, so what this will do is this one does not copy address to result in aliasing. So this is what it's not. Okay. Instead, it simply copy over the contents. So that's really important to know. Okay. It simply just copy over the contents. So how does it do that? So it simply does attribute by attribute copy. Attribute by attribute copying. We're copying every attribute value of EB2 into every corresponding attribute EB1. So now 15 over here is going to be copied over to EB1 over here. That's what we're doing. Okay, so it's not really assigning addresses because for EB1 and EB2, there's no addresses over here. Okay, so that's what it will do. And so after this, when we say EB1.I is equal to 15, that's actually true. EB2.I is equal to 15, that's also true. So this will be okay. So that's also true. Okay, finally, let's do something quickly. So now let's say EB1.change I over here 10. So EB1.change I to be 10. Okay, so you can see it's not affecting EB2, right? So now when we say EB1.I is equal to 10, in that case it is true. And EB2.I is equal to 15, that's also true. That's also fine, right? And now when we say EB1 not equal to EB2, in that case it's going to be true, right? Because you can see you're comparing 10 versus 15. They are not equal to each other, right? So that's actually true. Okay, hopefully that really illustrates to you the difference between the expanded type and also reference type. If you really want to do more, do one simple exercise for you, this is what I would suggest. I'm going to just make the exercise on the fly for you. Let me create a new page over here, and then the same example over here. I'm going to make some slight change for you. Okay, so now let's put this. This will be exercise. The only thing I want to do is this. Let's say we get rid of this expanded over here. That's the only change I make. And now, having this, I want you to think about, to consider this same fragment of code over here, to think about what kind of changes would it make as compared with the previous one. And also, if there's any compilation issue there, I don't know, in that case, how would you fix it? And once you fix the compilation error, how you can go on and do all the checks over here. Okay, so that'll be the exercise for you. Okay, that's the exercise. Try to do it to strengthen your understanding. If you really got confused about this versus this, you can ask me during the Q&A session. I will try to clarify further for you. Okay, so let's now go back to the slides. Okay, we have already talked about this example in detail, and don't forget the exercise where B is not expanded. Okay, I'll rely on you to complete it. Okay, let's now move on to one more detail, one more summary of the details before I present to you one design problem that you can solve. Okay, so let's say every time entity must be declared to be a certain type based on the class. So what I meant was it can either be referenced or expanded, right? We already illustrated the difference syntactically, so you should know how to use the keyword expanded. Let's say in the case of reference type, let's say y is simply a reference to some objects, meaning that y is going to store address of some objects. When you say x is assigned to y, you're really saying that you're copying the address that's stored in y into x. Diagrammatically, you simply just say x is now going to point to wherever y is pointing to. Okay, that's something you would have grasped from the previous OOP course. And then if you say x equals y, you're really comparing to see if x and y store the same address of the objects, meaning that if they point to the same objects, aliasing. Okay. So let's what about expanded types? Let's say, for example, let's say y is some objects of expanded type, right? Either you put expanded at the class level, or you put expanded in the variable declaration level. Either way, right? We talk about solution 1 versus solution 2. Now, if you say x is assigned to y, you don't really copy the address anymore, like in the case of the reference type. Instead, you really copy the contents of y, attribute by attributes, into the corresponding attribute in x. We already illustrated that in the example previously. And then if you say x equals y, it's as if you actually said tilde over here to compare by contents. Okay, so that's about the summary of details I would like to bring up, but you may have known that already. I think the only thing that's new is really about this section over here. Please just make sure you understand it, and if you want to experiment with the programming example, you can feel free to use iPhone New to create a new project to experiment. I'll leave that to you. Finally, I would like to conclude this part of the topic for expanded type by presenting to you one design problem here. Let's say this. Every published book has an author. Right? Let's say we got a book and we also got author, right? Different objects. Every author may publish more than one book, right? It's like a bidirectional relationship. So now, should the author field of a book, let's say you have a book class, and then you got one single attribute in the book class called author, right? So now, should that author attributes or variable be reference type or expanded type? Think about which design decision you will make and then justify it before you go on with my discussion. Okay, assuming that you paused the video and also thought about this issue over here, I would say whether to go with reference type author or expanded type author, either way is okay, depending on the scenario you're talking about. Okay, let me explain to you why. Okay, again, there's really no right or wrong answer whenever we talk about design. It's just that you have to justify for the particular problem context you're trying to solve. So it can either be reference type or author type, right? So now, for reference type, basically author will be shared by multiple books, right? So now let's say you got one book over here with this particular author. So you can see it's a little bit like a network object that we talk about. So reference over here, the reference for the author is simply pointing to this particular author. Okay, and then let's say this is another book that's published by the same author. That's why this particular field, like a network, is really pointing to this particular author as well. So this, you can think about this is more like when you go to a web page for a book. Let's say if you go to Amazon, and then usually the author field will actually be hyperlinked. And then in that case, you can simply click on the author's link and then go to that particular author's information. Okay, so you can think about by going through different books with the same author, you'll always be linked to the same author page. Okay, that's the idea. What about expanded type? For expanded type, it will be visualized differently. In this case, you can think about here, the author is, you can see the same author block, the same. However, they simply become an integral part of the corresponding book over here, meaning that if I want to change the information for my author, for example, for some reason, maybe this field of the information was simply just wrong. If I fix it over here, it doesn't fix this particular one, right? They're completely independent. So you can think about this scenario is more like a hard copy textbook, right? If I actually modify whatever that's in this particular textbook, hard copy, you wouldn't modify the other one. So you may have to modify multiple times, which may not be a bad thing, just reality, right? So as a summary quickly over here, so you got these two different solutions. You can think about over here, this part over here is really about sharing. Okay, this part here is really about composition. Oh, sorry, beg your pardon. It's really about aggregation whenever you talk about sharing. Aggregation, and then it's about sharing. On the other hand, over here you can see you got one integral part for the same author, you got another integral part of the same author, right? So now in this case, these two are really composition without any sharing. Composition, no sharing. Okay, let me just mention a little bit more details over here. You can think about maybe you have one class over here that's simply just called author. And then, of course, you may have various attributes over here. I'm going to omit the details here. You can have the name, maybe the date of birth, maybe affiliation, institution, etc. Right? Different information in the author class. Right? So now, for this particular solution here, for solution number 1, what you're doing here is you say class, let's say book. Because it can be shared, so you will simply say author over here of type author. And then, of course, you might have other attributes in the same class, right? That's solution number 1. So what about solution number 2, where the class is actually expanded, right? So now in this case, you can either change this particular class to be expanded, but that will actually eliminate the flexibility that sometimes you may want to be shared. So we may want to go with solution number 1 that we talked about previously, right? So let's see how we can do it. So now for this particular case over here, what you will get is you're going to say class book, second version over here, and now you can say author over here is simply expanded of author. And then, of course, that would be the end of the class. Of course, you got other details here. So now you can see the difference is, okay, that's the second solution over here. Okay, so let's say this. You can see the second solution is really about this. We are referring to the same author class, but now this is expanded, right? So you can see the flexibility over here. Whether to go for this solution over here or this solution here is completely up to your justification for your problem context. Okay, so hopefully this case study here really help you to say going forward whether to use expanded or not is really up to your justification for the design that you're trying to solve.